Chapter 5 Periodic Table. Subtopic: Patterns in periodic table. Changes in physical properties in periodic table. Changes in chemical properties in periodic table. Patterns in periodic table. Core electrons are electrons that reside in the inner energy levels of an atom. Valence electrons are electrons that reside in the outer shell, principal shell containing electrons with the highest quantum number, of an atom. The periods in the groups of elements in the periodic table correlate closely with the electron configurations of the elements. The elements in the periodic table are arranged in the increasing of proton number, which increases from left to right across the table. A horizontal row of the elements in the table is called period. Each period is numbered 1, 2, 3, etc. Number of vertical columns is known as group. Each group is numbered as IA, 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 VAR, VA, VIA, VIA and VIA. The periodic table also has 3 other blocks of elements, known as the transition metals element, lanthanides, and actinides. Transition metal element consists of incompletely filled the D subshells, while the other 2 blocks are called as the F block transition metal elements because they have incompletely filled F subshells. Elements which have incompletely filled S or P subshells is divided into several groups. Some common name of the groups: Group E, also known as alkaline metals. Group I, also known as earth alkaline metals. Group V, also known as halogen group. Group V, also known as noble gases. The chemical activity of the elements is determined by their valence electron or electrons which located at the outermost shell. Elements are classified to their specific group depends on their valence electron. Elements are classified to their specific period depends on the number of shell of the atom. All elements in the same groups have the same number and type of valence electrons. Therefore they have similar chemical properties. The representative elements, or the main group elements, are the elements in groups IA, or 1, through 7A, or 17, all which have incompletely filled S or P subshells of highest principal quantum number. Elements in the same group have similar valence shell electron configurations. The number of valence electrons in an element represents the group number of the element in the periodic table. The period number of the elements is the principal quantum number of the outermost principal energy shell in an atom. Across the second and third period of the periodic table, there is a gradual change in properties, from the alkali metals to the halogens. The fourth period begins in the same way with potassium, K, and Ca. These elements are called the transition elements. These 10 elements from Sc to Zn form the first transition element series. Changes in physical properties. There are some changes in physical properties of the elements when it's going across the period and going down the group. The changes are based on A. Atomic size, B. First ionization energy, C. Electrons affinities, D. Electronegativity of the electrons. Atomic size, atomic radius. Atomic size of an element is 1/2 the distance between the 2 nuclei in 2 adjacent metal atoms. Decrease from left to right because increase in effective nuclear charge, same as valence electron, which cause the valence electrons to be held more strongly by the nucleus. Increase from top to bottom because the principal quantum number, an increase which causes the outer electrons to be far from the nucleus. Going across the period, the atomic size of an atom is decreases, and going down the group, the atomic size is increases. The atomic size is referring to the distance and attraction force between nucleus and valence electrons. Going across the period, the number of valence electrons increase, but the number of shell is unchanged. Example, NaCl. Number of valence electron of Cl is higher than number of valence electron of Na, so the attraction force of Cl is stronger than Na. That's why atomic size of Cl is smaller than Na.
Created using Powtoon.